Hey everyone. A couple months ago I designed this thing, and if you don't recognize it, it's the hoe-based flying machine, the absolutely not perfect solution to long-distance transport. The purpose of the machine is quite simple. All you have to do is sit inside of this minecart right here, and then keep hoeing this dirt. Every 21 blocks, this feed tape makes a full cycle, and you use up exactly one durability point on your hoe. For every durability point on your hoe, therefore you'd fly 21 blocks, and you could very easily encode a very specific flight distance into the machine just by breaking a hoe a very certain amount. Now, don't get me wrong, this thing absolutely works. The problem arises in the fact that it works in the same way that it totally works to use nail clippers to mow a lawn, and that it's an incredibly stupid solution to a problem that doesn't even exist. So I guess I'm gonna take my hand and try and make it better? Now, here's the fundamental problem. Making an idea that's inherently stupid better usually just makes it more stupid, and I think that's exactly what happened here, because most of the results I produced are arguably far worse of a solution to the same problem that yet again doesn't even exist, but I still did it anyways. So then let's begin. Let's talk about how I got to designing this comically stupid airship that does exactly what the previous one did, only without the hose. Now, for the previous video I received a lot of comments that basically went something like this. Just add more counters. And that basically just allows the machine to count to higher numbers and therefore fly farther, the same reason why adding more digits to a base 10 number allows you to count more numbers. Now, don't get me wrong, there's nothing wrong with this solution because it's actually exactly what we're going to be using. The only reason I didn't touch it was because, number one, I had already thought of it, because it was actually the first thing I tried before even implementing the hoe system, and number two, I had no idea how to do that. See, the fundamental problem actually comes from the fact that observers really love to power everything around them whenever the flying machine moves. When I push it, every observer fires. This works for the previous flying machine. If we looked at a counter very similar to the one on the previous one, every time it moves forward, the entire thing cycles. And that's okay, because it wants to cycle. Every time the machine moves forward, all the observers want to be powered. Thus, we end up with a counting system that is changing every single time we move a block. Here's the problem when we add more. If we look here, now we have two counters, a tens place on the left and a ones place on the right. The problem arises in the fact that if we look at the tens place, it has to stay the same. And this really goes against the observers because they really want to fire every time we move. But we want to keep this tape stable. The problem is also exacerbated by the fact that eventually we want to also fire it on purpose to get it to change every time we need to carry the digit. So, in order for us to make this work, we need a counter that can stay stable, but also fire when it receives the order to from the counter below it. Does that make enough sense? I promise it'll get easier from this point on. So, what we eventually ended up with was this piece of garbage. As you can see, it works. Now, the problem is, you might notice there in the end there, it is really inefficient. It has a lot of times where it's just firing, which is going to make it really hard for it to move fast in the future, and it also sucks in a bunch of other ways. But it's still an important step to take a look at because it shows that the prototyping design process is essentially a lot of garbage to start with that slowly gets better. First things first, let's look at the innovations we're using. Here, right here, in order to prevent this sticky piston, which pulls the blocks down when they come back whenever we actually do a cycle, as you can see, in order to prevent this from constantly firing every time we move, we have a piston up here, which actually fires, making it immovable, stopping the sticky piston from extending. The rest simply just fires a bunch of times in blank spots, causing no damage to the feed tape. This is how we can stabilize it, yet still offer it the ability to cycle a feed tape. If we look at this next machine, this is kind of me putting into practice. We've got the first timer here, the one that always counts every single time, and then we've got our counter that only counts every once in a while. If we go ahead and actually fire this, as you can see, this timer is cycling, but when it completes a full cycle, it causes this one to cycle. That means that you essentially multiply the amount of blocks in this counter by this one. Ideally, we'll be able to keep stacking them and eventually create ludicrously high distances. Now, it's right about here in the development process that you're going to watch me make a pretty huge mistake. See, I just took one look at this machine, tested it a couple times, and I was like, yeah, that works. Let's just scale it up 3 times. And then I ran into a bunch of unforeseen problems. Some of them were caused by the fact that we are now stacking them. There were problems with the digits carrying over, and a billion things I couldn't see. One of the biggest problems was the fact that we're actually taking an observer output from the feed tape. And if we happen to move this system while the observer is in front of this one, it's going to take an extra pulse and cause this piston to get another chance to fire when this piston wasn't extending, completely destroying the mechanism. Alright, time for a little bit of a tangent. You see, you may have seen me use this machine a little bit right here, this one, and the thing is, I didn't design it. See, when I initially released my hoe-based flying machine on Reddit, I essentially got schooled by this person, I don't know how to pronounce that, and they just sent me an image containing 5 or maybe 3 flying machines, all like this one, that were just a lot better than the core of what I had designed. See, they used a really interesting idea. We don't need a piston to push the blocks back in the feed tape. For most feed tapes, we have to cycle the entire thing, so you need 4 pistons in every direction, but since the flying machine is inherently moving forwards, we can just let these top row of blocks just lag behind. And this totally just works. I can't believe I didn't think of that, so massive thank you to this lovely person who has definitely heavily aided me in the design process of my stupid machines. I'm also going to take this quick tangent to say the reason why there are so many lecterns everywhere is just I designed this project like 2 weeks ago and I actually had no idea when I was going to actually get to filming it, so I really just kept track of what everything did so that I could remember and talk about it. Now, on to the next thing. I'm going to quickly gloss over this machine. This is the equivalent of essentially trying to sail across the Atlantic and ending up in Australia. This machine is just a version of that works backwards, like the feed tape is functional from this end. No clue why I decided to do that, and it's a total waste of time because it doesn't even work in the first place. Next, finally, we've got something useful. This is the actual design we're going to be using in the full thing that's like way over there. See, this works perfectly. As you can see, it moves forward, and we're going to be using this sticky piston, which kind of cycles it. So, how did we actually solve all the rancid problems with the previous design? See, in this system, we're using more of a passive cycling system, whereas in this design, we're using a very active cycling system. What I mean is that we detect how often this thing is cycling by using observers to directly read the feed tape. We can see when this thing cycles, when this piston decides to move, because all these blocks are going to move, triggering these 2 observers. In the other approach, we have no observers reading the actual piston feed tape. The entire thing will run completely autonomously the moment that we trigger this piston. You see, only 2 pistons activate, the rest is just going to happen as the machine moves forward. As you can see, the next step, this piston is going to trigger, and it's going to put everything back into place. Another thing that we use to optimize it is we actually incorporate the ideas of the flying machine that the person sent me, and letting the blocks lag behind. See, we completely save on that piston that we had to install at the end there, and that further helps to optimize the design. Okay, so what I'm going to do next might surprise you, considering the little fiasco over there, but what I basically said was, oh, this works, why don't we scale it up 4 times? And that's what I did, and it actually did work, so that time it paid off, but still don't do that when you're designing things, it's a stupid idea. Now, in order to demonstrate that it actually works, I've gone ahead and put all the observers in the right place to do a final cycle on the last counter, and if we punch it forward, watch the system, we're going to see that every single counter moves its blocks forward. And that's about it for storing data on top of moving flying machines. This setup can achieve about 160,000 blocks of possible distance, which is just about double as the previous one could, and simply sticking on 2 more modules allows you to count to whatever distance it is traveling from one end of the world border to the other. Now, there's still a couple problems that we still haven't solved. The thing is that for the variety of testing, I've just been using this little singular target block flying machine. We need an actual engine, and we're going to be running into some unforeseen problems involved with making an engine that is capable of stopping every 20 blocks in order to let the digit carry over, as well as involving an entirely different flying machine on top that restarts the engine again. We'll also talk about how we can introduce a braking mechanism in order for the machine to stop when we actually reach our destination, and how it all ties together. So if you want to check that out, make sure to like and subscribe. Also check out my other videos while you're at it, and stay tuned for the next episode.